All right. The zeros of a quadratic function. The x locations of any function where the output, the y coordinate, is equal to 0 are known as, surprisingly, the zeros of the function. Well, we already know that. We learned that on the first day. We said that the x-intercepts are called the solutions, the roots, and the zeros. Why? Because that is where y equals 0. The value of the function is 0. These are amazing and important. These are amazingly important in applied settings. When they are rational numbers, they can be found using a factoring technique. I'm going to help you, honey. Okay, you got it? All right. So consider the quadratic function y equals x squared minus 2x minus 3. It says, what are the zeros of the function? That's the same thing as saying, what are the roots or the solutions? So look at the graph and let's circle them on the graph. What are the zeros or the roots? Well, there's one right here. And there's one right here. Do y'all see that? Okay. It says write their x values down. Write down the x values. Well, what are those two x values where I cross the axes? Yeah, x equals -1 and x equals 3. Verify the positive 0 is correct by showing that it makes y equals 0. That's what that's saying. So I'm going to take my function right here. Is it working now, hon? Okay. So y equals x squared minus 2x minus 3. And I need to take my positive 0. Which value is my positive 0? Say it again. 3. And I need to plug that in. So I need to plug in the value of 3 for x. So let's see. Y equals parenthesis 3 squared minus 2 parenthesis 3 minus 3. So you can put that in your calculator, or we can just kind of math it out. What is 3 squared? 9. So y equals 9 minus 2 times 3 is 6 minus 3 more. Let's see. What is 9 minus 6? 3. What's 3 minus 3? So what does y equal? Y equals 0 when x is 3. That means it's a root. So we just verified that, okay? Now we're just going to look at the quadratic expression. We're going to ignore the y, and we're going to factor it. So let's see. We're going to factor this expression. So I'm looking for two numbers that when I multiply them, I get a -3, but when I add them, I get a -2. What are two numbers that when I multiply them, I get a -3, and when I add them, I get a -2? Violet. -3 and +1. So that means I'm going to factor this as x minus 3 times x plus 1. It says, how do these factors compare to the zeros? Remember that the zeros are x equals +3 and x equals -1. Those are your zeros. How do they compare? How does x equal +3 compared to x minus 3? The question is, how do the factors compare to the zeros? Well, what do we know about the factors? The factors and the roots are what? Opposite signs. They have opposite signs. We know that. So it says, based on C, determine where the zeros of this function are algebraically. So here's what this means. We're going to set our y value. We know that we cross the x-axis when y equals what? We cross the x-axis when y equals what? 0. So we're going to rewrite this equation as 0 equals x squared plus 3x minus 10. And we're going to factor it. Well, we already did factor it. We know that the two factors are x minus 3 and x plus 1. And I told you yesterday and the day before, when we factor, we know that if the factors, like if we know what the factors are, we know that the roots are opposite. So what are the roots? If I have x minus 3, the root is x equals 3. And if I have x plus 1, the root is negative 1. It says verify this using a table. So someone please go to their calculator. Someone please pull up their calculator and put in the equation under y equals, do x squared plus 3x minus 10. And please verify that when x is negative 1, y is 0. And when x is positive 3, y is 0. What do we get? You're putting in the equation y equals x squared plus 3x minus 10. Go to your table. Head up. What did you get? Is anyone doing that? Yeah? What'd you get? Who's putting it in their equation? What'd you get, Ashton? No, when x is negative 1, what is y? You did x squared plus 3x minus 10? Oh, I'm doing the wrong equation. I'm sorry. I just copied this. This gave us a whole new function. I didn't even see that. Did you guys see that it changed the function? Sorry. So we're going to do the same thing, but we're going to factor this. We don't know these factors yet. Yep, erase it. I'm sorry. Or just scribble it out. Yeah. Sorry. Just scribble it out. What are two numbers that you can multiply together to get negative 10 that when you add them, you get 3? It's because my notes are over there. 5 and what? 5 times what is 10? 2. If I need a negative 10, how about if I take 5 times negative 2? So my roots are x plus 5, or my factors are x plus 5 and x minus 2, which means that my roots are negative 5 and positive 2. So keep that equation in your calculator, and when x is negative 5, verify that y is 0. Yes? Is that what you got? Who's got it pulled up? Yeah? And when x is positive 2, is y 0? Yeah, I'm sorry about that, guys and gals. I was just jumping ahead. All right, so the most important equation in solving technique is known as the zero product law. I want you guys to think about multiplying two numbers and you get a solution of 0. So let's just think about that for a second. If I said 4 times x, we don't know the value of x, equals 0, what does x have to be? X has to be 0. Any number times another number, if it has a product of 0, that means that this has to be 0, right? Someone's at my door. This is called the zero product property. It says if you take two numbers and you multiply them together and one of them is 0, then either the first number or the second number or both are 0. It's just called the zero product property. So here's what this is saying. Think of this factor. This factor is just like A. This is no different than saying A times B equals 0. And it says, well, if A times B equals 0, then either A equals 0, which means x plus 7 equals 0, or B which is x minus 2, that equals 0, or both? Well, these are the factors, right? And I told you that the factors and the roots have the opposite sign, and here's why. It's because of the zero product property. If I want to solve for x, I have to subtract 7 from both sides. And that tells me that x equals negative 7. So the factor x plus 7 creates the root x equals negative 7. You guys have been doing that since Monday. Now you know why. It's the zero product property. If I have a factor x minus 2, it has to equal 0. So I add 2 to both sides, and that tells me that x, my root, is positive 2. Again, we said on Monday that if your factor is negative, right, the root is the opposite sign, positive. Here's the why. It's because of the zero product property. So now we're going to use these two factors, and we're going to set them each equal to 0. So 2x minus 1 equals 0, or 3x plus 4 equals 0. We're finding the roots. We're finding where, this is telling us where the graph crosses the x-axis. That's what this is giving us. This is where the graph crosses the x-axis. Okay? So how am I going to simplify or solve for x in that first equation? 2x minus 1 equals 0. Add 1 to both sides. So that gives me 2x equals 1. And then what? Yeah, divide both sides by 2. So that means that x is 1/2. So I know that I cross the x-axis at the point 1/2 on x, okay? Or the ordered pair 1/2, 0. How do I solve the next one? 3x, say again? Yeah, subtract 4 from both sides. So 3x equals negative 4. Keep going, Gianna. Divide both sides by 3. Yeah, so that means that my second root crosses the x-axis at negative 4/3. So I'm just going to sketch a really quick graph of this one, just so you guys kind of get an idea of what this helps you do. So I'm going to say that this is the positive number 1. This is negative 1. And I'm going to say that my first root is positive 1/2 right here. And my second root is negative 4/3. Where does my graph cross the y-axis? At C, which is these two numbers. What is negative 1 times 4? Where's negative 1 times 4? Or what is negative 1 times 4? It's negative 4, so that's my y-intercept. So if this is negative 4, this graph looks like this. It's a down and dirty sketch. Let me extend it a little bit. Okay. I don't know why that keep, well, that's ugly, but that's what it's going to stay as. Sorry. Got it. Okay. We ready to keep going? Okay. Sorry about the big black line, but it is what it is. Okay. So the zero product law is remarkable because it allows us to solve equations with x squared or higher, right? So we're just going to focus on x squared today. Tomorrow we'll look at a couple of x cubes, thinking it in terms of volume. So we're going to find the roots to the solution by factoring. So we're going to find where these quadratics are going to cross the x-axis. So we have to factor it first. So first we factor, and then second we set each factor equal to 0 and solve for x, which is exactly what we did on the first page. So let's look at example A. I'm looking for two numbers that multiply together to give me negative 12, that when I add them, I get a positive 4. How am I going to look at this in my calculator? Y equals negative 12 divided by x. Positive 2 and negative 6 will give me a negative 4 when I add them together. You're really close. Yeah, how about if we do positive 6 and negative 2? Just write it down, positive 6 and negative 2. So that means my factors are what, Kimber? The factors you use are the factors you choose. So my first factor is x positive 6 plus 6. And my second factor is x minus 2, right? That's what it looks like. Each one of those have to be set equal to 0. So that means that either x plus 6 equals 0 or x minus 2 equals 0 or both, right? So how do I solve x plus 6 equals 0? What do I do, Jansen, to get x all by itself? Carla, pick your head up. How do I get x all by itself, Jansen? Right here. What do I need to do to get x by itself? Subtract 6 from both sides, right? Yes. X equals negative 6. That's the first place that it crosses the x-axis. And on the second one, I'm going to add 2 to both sides. So the other place that I cross the x-axis is at positive 2. Are we getting this? Are we not getting this? What is making this so hard? We're solving a 1 or a 2-step equation. Okay. Example number B. How in the heck am I going to factor 2x squared minus 14x? Well, let's see. I know that when there are two terms, when there are only two terms, I look for a GCF and I try to see if it's dots. Well, is this a dots? No, 2 is not a perfect square and there's a B term. So it's not dots. So that means it's got to have a GCF. What is the GCF? 2x. I can take a 2x out of both terms. So when I take my 2x out, what do I have left? Well, 2x squared divided by 2x is x, and negative 14x divided by 2 is equals 0. So that means that my first factor, either 2x equals 0, or my second factor, x minus 7 equals 0, or both, right? That's what the zero product law says. Okay, so how do I solve 2x equals 0? How do I get x all by itself? God bless you. Divide both sides by 2. What is 0 divided by 2? 0. Do you remember yesterday I said, well, whenever you just pull an x out by itself, that's 0. That's why. Okay. What do I do on the second one, Jansen? How do I get x minus 7 equals 0? How do I solve for x? This says x minus 7. What's the undo of subtract? Add 7. Add 7. So x equals positive 7. These are the two places where my graph crosses the x-axis. What about example number C? It's got two terms, so let's see. GCF or dots? Or both? Dots. Good job. This is a perfect square. What is the square root of x squared? X. What is the square root of 25? 5. What do I put in the middle of those two factors? One gets a plus and one gets a minus. Set them both equal to 0. Okay. So let's see. That means that x plus 5 is 0 or x minus 5 is 0. If x plus 5 equals 0 and I subtract 5 from both sides, what is the value of x? Negative 5. If x minus 5 equals 0 and I add 5 to both sides, what is the value of x? Positive 5. You guys are going to get to the point that you know the root has the opposite sign as the factor, and you're not even going to have to write down the factor equals 0 and solve. You're just going to be able to look at it and solve, right? Just like you did it yesterday. I mean, you've been doing this. What about example number D or letter D? Well, I have to do slide and divide. So x squared plus 5x minus 24 equals 0. So what are two numbers you can multiply together to get negative 24 that when you add them, you get 5? Factors of 24, 2 and 12, 4 and 6, 3 and 8. So if I use 3 and 8, which one has to be negative? The 3. X minus 3 times x plus 8 equals 0. Pay attention, both of you guys. I see exactly what you're doing. I'm moving your seats tomorrow. X plus 8 equals 0, and x minus 3 equals 0. So that means x equals 3, and x equals negative 8. Those are where you cross the x-axis. Those are where you cross the x-axis, okay? So you guys have been using the zero product property without knowing that's what it was, correct? Because if you wanted to find the x-intercepts, I told you to factor it and then just use, like, you factor it and then the roots are the opposite sign. True or false? That's what we've been doing. Don't let this whole concept of now we set them equal to 0 is so hard. It's not. You're doing the same thing. If the factor is a plus, the root is a minus. That's it. Okay? Got it? All right, last example. It says find the zeros of this quadratic function algebraically. Well, y equals 3x squared minus 6x minus 24. That means we have to factor it. And if we're finding the zeros, that means we have to let y equal 0. So 0 equals 3x squared minus 6x minus 24. Does anyone see a GCF that we can take out first? 3. Divide everything by 3. So 0 equals 3 times x squared minus 2x minus 8. What two numbers can you multiply together to get negative 8 that when you add them, you get negative 2? Four and 2. Which one has to be negative? My sum is negative 2, so the 4 has to be negative. So 0 equals 3 times x minus 4 times x plus 2. If my factor is x minus 4, what is my root? If the factor is x minus 4, what is the root? X equals positive 4. If my factor is x plus 2, what is my root? X equals negative 2. Absolutely. So let's see. I'm going to put 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So when I break my number line into 5 increments, right, I'm going to plot x equals positive 4 right here. And I'm going to plot x equals negative 2 right here. Here's a trick to finding the axis of symmetry. How many spaces? Let's see. 1, 2, 3, 4, 5, 6. There are 6 spaces in between the roots. What's halfway between 6? 3. So that means that my axis of symmetry is right in the middle at 3 spaces. 1, 2, 3, right here. This is the axis of symmetry. So let's find the vertex. If The axis of symmetry happens when x equals 1. Let's plug it in 1 to find the vertex. And I'm going to use the factored form. 3 times 1 minus 4 times 1 plus 2. So what's 1 minus 4? -3. And what's 1 plus 2? 1 plus 2 is 3. What is 3 times -3 times 3? 3 times 3 times 3 with a negative. Yeah, it's -27. So this is my vertex at the ordered pair 1, -27. Well, where do I cross the y-axis? At -24. So let's see, if this is 10 and this is -20 and this is -27, -24 is about right here. And that's 1 unit away from my axis of symmetry on the left. So I'm going to go 1 unit away on the right. And there's everything I need to plot my graph. That's everything that you need.